The Antikythera mechanism is a famous artifact which was discovered in 1901 in the remains of a 2,000-year-old Greek shipwreck. Through the efforts of researchers, it was revealed to be an ancient astronomical calendar which displays the positions of the Sun, Moon, and planets for a given date. Part of what makes the Antikythera mechanism so complicated is that the device models a geocentric system in which the planets appear to orbit the Earth, rather than the solar system we understand today. The reproduction presented here was handmade by Dr. Alistair Godfrey. It is a modernized version of the Antikythera mechanism, featuring the Roman 12-month calendar in place of the ancient Greek Saros cycle. The outer dial and long pointer on the front face indicate the date, and the rear spiral shows the year. The inner front dial is used with the remaining markers to show the positions of the celestial bodies. These positions are described along the ecliptic, which is the line along which the Sun, Moon, and planets appear to move in the sky. The zodiac constellations also sit along this line, so as the Earth orbits the Sun and planets appear to move through the zodiac. The inner dial numbers from 0 to 360 degrees describe the angle from the first point of Aries, the location of the Sun at the spring equinox, to the position of the planet. Here we will show you how Alistair made an individual cog for the mechanism. First, he begins by marking out a circle, which he cuts from a brass plate. He bores out the centre and mounts it on an arbor in the lathe, where he machines it to size. The wheel blank is transferred to the milling machine, where it is checked for concentricity, and the cutter is moved to the correct centre height. Finally, the wheel is indexed using a dividing head, and the teeth are cut with a shop-made fly cutter. One effect of the geocentric model is that the planets appear to move at varying speeds through their paths, sometimes falling behind or overtaking other planets. Mathematically, this motion can be achieved by superimposing two sine waves. To achieve this mechanically, we can use a pin and slot mechanism combined with a gear train. here is a basic model to show how this mechanism works in its simplest form. We start with 2 arbors and a total of 4 wheels. On the arbor on the left, the center of rotation of the top wheel is slightly offset from that of the bottom wheel. A vertical pin in the bottom wheel engages with a slot in the top wheel. This results in a varying speed difference between the bottom and top wheels. Now we add 2 wheels on the right, which will mesh with the wheels on the left. As you can see, the top pointer is fixed to the bottom wheel, and the bottom pointer is fixed to the top wheel. As we rotate the mechanism, the pointers move at different speeds relative to each other. This forms the basis of each planetary gear assembly in the Antikythera mechanism. Thank you for watching this video. If you enjoyed it, please consider subscribing.